Good morning, students. It's another opportunity to consider the best subject you can ever study, chemistry. Like I tell everyone who cares to listen, chemistry is the easiest subject. However, you need to know the basics. Today we're looking at an important concept, and that is oxidation number. For a lot of people, it seems to be an issue. However, knowing the basics will actually clear your doubts. The first thing is, what do we mean by an oxidation number of an element in a molecule or an ion? Oxidation number refers to the electrical charge that an element appears to have as determined by a set of arbitrary rules. Now, this implies that there are certain rules you must know in order to deal with oxidation numbers. The first thing you must know is that when an element occurs freely in nature, or an element that is actually free uncombined has an oxidation number of 0. For instance, sodium in the combined state, sodium 0, the chlorine molecule uncombined. So when an element occurs freely, it has an oxidation number of 0. Now, however, if an element occurs in a combined state, there are certain rules to determine the oxidation number of the element, especially if the element exhibits different oxidation numbers depending on the compound or the molecule involved. Now, the question is, how do you go about that? The first thing you should know is that another thing you need to know is that an element that occurs in a simple ion has the size and charge of that ion. For instance, magnesium 2 positive, the oxidation number is actually a +2, and then chlorine negative, the oxidation number is a -1. You can see that this occurs in an ionic state, and the oxidation number is taken to be the charge of that ion. Now, the next thing you need to know is that there are standard oxidation numbers for two main elements, and that's for hydrogen and oxygen. Hydrogen always exhibits oxidation number +1, except in hydrides, while oxygen exhibits oxidation number -2, except in what? In peroxides. So I will repeat myself again. Hydrogen has an oxidation number of +1, except in hydrides, where it actually has an oxidation number of -1, and oxygen has an oxidation number of -2, except in peroxides, where it has an oxidation number of -1. And then, if you know this, you are able to deal with any problem in oxidation numbers. Let's look at some examples that will be very helpful for us to deal with this. Now, let's look at certain examples. For instance, you have this hydrogen sulfide. Now, this is actually a compound, and then you must know that the total sum of the oxidation numbers in a compound gives 0. The algebraic sum of the whole oxidation number in a compound will be equated to 0. So if that's the case, remember I've told you that hydrogen is +1, so we can write this 2 times +1 plus the oxidation number of sulfur, which is unknown in this case, should be equated to what? To 0. If that's the case, 2 times 1 will give us 2 plus x will give us 0. And then if you do that, you will now discover that x is equal to -2. Hence, the oxidation number of sulfur in this case is -2, and it's actually called hydrogen sulfide. Let's take another example. For instance, if you have this is actually called carbon dioxide. However, when we get the oxidation number, we are able to name it correctly. Now, in this case, remember that I've told you that the oxidation number of oxygen is actually -2. Hence, the unknown is called X. So X plus 2 times -2 is equated to 0. Remember, it is 0 because it's a compound, and the algebraic sum of oxidation numbers of a compound is equated to 0. And this would X plus -4 equals to 0, and therefore X minus 4 equals to 0. Hence, you will have it that X equals to +4, and this is why it is called carbon dioxide. The oxidation number of carbon here is +4. Now, we can even have examples that are quite complex than this. Watch out for them. Now, let's look at those examples, complex examples. What if you have something like this? And then you're told to find the oxidation number of manganese in this case. Now, you should know as a chemistry student that the oxidation number of potassium is +1 because it is a group 1 element. And then for manganese, it's unknown. Oxygen -2. Then if that's the case, this becomes +1 plus X plus 4 times -2. The reason why this is 4 is because the number of oxygen atoms here is actually 4, and then everything is equated to 0. Remember, I told you that the algebraic sum of the oxidation numbers of a compound will give us 0. And then this will be 1 plus X plus -8 is equated to 0. 1 plus X minus 8 equals to 0. And then this becomes X equals to 8 minus 1. And it gives us +7. And actually, the oxidation number of manganese in this case is a +7. And that's why it's called potassium tetraoxomanganate 7. Now let's look at the last example of a complex compound. Actually, the third example is that of sodium dichromate 6. Now, here sodium is taken to be +1 because it's a group 1 element. Oxygen, like I've told you, has an oxidation number of -2, and chromium has an oxidation number of X, meaning unknown. So what do? 2 times +1, and the +1 is because sodium is +1 plus 2X. The reason why we have 2X is because chromium is unknown, and then we have 2 atoms of chromium. And then 7 for oxygen times -2, and then 2 times 1 will give us 2X, and then 7 times -2 give us -14, equated to 0. Remember, it is 0 because the algebraic sum of the oxidation numbers in a compound sums up to 0. And then plus 2X minus 14, and eventually we get it that X is equals to +6. And that's why this is called sodium heptaoxodichromate 6. The oxidation number of chromium in that case is actually 6. Now, you can also have situations where you are not looking for the oxidation number in compounds. Instead, you're looking for the oxidation number of atoms in ions. For instance, if you have something like this, SO4 2-. Now, tetraoxosulfate 6 ion. Now, in this case, you are told to find the oxidation number of sulfur. Now, when it's actually an ion, remember that the algebraic sum of the oxidation number will be equal to the overall charge. So, what we'll be having is that we don't know the oxidation number of sulfur, so it's X plus 2 times plus 4, times -2 is equals to minus 2. Remember, it's equated to minus 2 because that is the overall charge of that ion or radical. Now 4 times minus 2 give us minus 8 equals to minus 2, and this will give us x minus 8 equals to minus 2, and therefore this will be x equals to minus 2 plus 8, and therefore x is equals to plus 6. And this is the reason why it's called tetrahedral of a 6 ion, because the oxidation number of sulfur is actually plus 6. Now you can have something similar. Imagine that you have phosphate ion PO4 3-. Now, and we are told to find the oxidation number of phosphorus here. Now, what do we need to do? Remember that if it is an ion, then the algebraic sum of the oxidation number should actually give us the overall charge. So that will be x for phosphorus plus 4 times minus 2 is equals to minus 3. And this will be giving us x plus minus 8 equals to minus 3. And this will be giving us x minus 8 equals to minus 3. And this will give us x equals to minus 3 plus 8. And this is x equals to plus 5. So here, the phosphorus is actually having an oxidation number of what? Plus 5. So when you are told to find oxidation numbers, this is what you should do. Remember, if it is in a free state, the oxidation number is actually 0. However, if it is a compound, the algebraic sum of the oxidation number should give you 0. But if it is an ion, then the algebraic sum of the oxidation number should be equated to the overall charge. I know you've learned a lot about oxidation number. If you have issues with compounds and then ions that are giving you issues, I think you can relate them to me. However, with this, you can solve everything under oxidation numbers. Thank you.